I'm going to talk today. Let's see if my clicker works. That's the main thing. Is your clicker works? You got your technology going. You're good. Because I just gave a keynote talk at a conference, and I got up here and nothing worked. So today it's good to have something work. So I'm going to talk today about this system management project, product, whatever you want to call it. That's different from whatever you've seen before. People ask me, well, how is it like this? And I said, well, it's not like that, even though, well, how can it be that different? And the answer is, well, it is. And I think you'll see that as we go along here. And as it mentioned here, here's my biography. This is what he just said, more or less. An alumnus, that means I don't work there anymore. In some cases, it meant I left, and in some cases, it meant that I graduated, if you understand my meaning of that. I think the thing to start with, though, is to look at the trends. These are real numbers. I didn't make them up, and they're not my statistics. 30% of all break-ins from the outside come through systems people have lost track of. There are a variety of ways to lose track of computers. If you've managed them for a while, you've probably experienced some of them. My favorite one was the one where they knew the computer was still here, but they literally couldn't locate it, so they traced the cable, and it went behind a blank wall. And they discovered that someone had walled it in, and it had been there for the last 5 years, behind, drywalled in, covered with construction crap, And that's how it was for years, and they finally had to tear the wall down to get to it to maintain it. Well, that's not how you usually lose things, but that's a true story. At least I'm told it's true. And I've heard enough other stories and seen enough other things myself to believe that, yeah, this kind of stuff happens. People do misplace computers, logically or physically. Logically is the easy one, actually, because you can go down your rows and count things, unless they're behind a wall like that. But you may not know what they're doing. You may not know that much about them. And so 30% of all break-ins come through lost systems. So if you keep track of your systems and there aren't any that are off the books, then you have a 30% chance, a lower chance of a break-in from the outside. That's a good thing.
We can virtually lose servers now.
Oh yeah, exactly. You can virtually lose servers. You can have them in the cloud. You can have, the word I've heard for that is VM sprawl. It's so much easier to make a computer that you could lose now. Before you had to you could touch it. Now you can't touch it, so you can't find them in that sense. 90% so there's a study done by James Turnbull on monitoring, and 90% of the people he surveyed, and they were Puppet and Chef users, so they're kind of leading edge compared to the rest of the world. 90% of them admitted, well, we've had services where we weren't monitoring, and it went down, and it took us a long time to figure out what was broken. 90%, and that's of the leading edge people. When I tell larger audiences this, I say, how many people think the real world is worse than that? It's like, oh yeah, way worse than that. 80% of the people who get their systems into compliance are unable to keep them there. That's a Verizon study based on PCI compliance. But the principle's the same. That it's like eating an elephant to get into compliance, but you have staff changes, you have changes in regulations, you have all kinds of things that change, and people who make changes on the system who aren't aware of all the. How many people think that your administrators are aware of all the regulations that apply to your computers? Yeah, no, it doesn't happen. And so if they don't know them, they're not going to enforce them. They're not going to carry them out. Welcome. And so 80% of the people who've spent the effort to eat the elephant find themselves eating the elephant annually, which means that they do it under high stress conditions. Either an auditor has come to find them, or the security team has come to find them and says, "You did what? These bad guys got in behind our firewall and are doing all this stuff because you thought that was a good idea." Those are not the kind of discoveries you want to make. 30% of the people of this same group of people that are sort of the leading edge admit that, well, we really only start monitoring stuff once we realize we have a problem. That's pretty serious, but apparently from the audiences I've talked to, people think that number is low for the world at large. And going on from here, Turnbull says, and this is more of his opinion based on conversations. It's not part of his survey statistically. Larger sites have trouble scaling monitoring. When you have thousands or 10 or even hundreds in some cases of servers, they often find that the monitoring software doesn't really scale the way they want. It winds up getting complicated. They wind up having to do all kinds of weird things in order to get everything monitored. Of course, If you're the sales guy, it's not a weird thing. If you're the guy deploying it, it's a weird thing. So it's all a matter of perspective, right? We got to that. Often, your site administrators don't know the dependencies, client-server dependencies, of how all the puzzle pieces fit together. That's not at all uncommon that people would not know that. And documentation is typically incomplete, out of date, and expensive. One of the things I like to say is there's three kinds of documentation. There's the most common kinds of documentation you do not have. The second most common kind of documentation is documentation which is incorrect today or out of date. And the third and last kind is documentation which will be out of date tomorrow. So there isn't a fourth kind. You know, if you have documentation and it's created by human beings, it will be out of date. It's a question of when and how much you're willing to spend to keep it up to date on an ongoing basis. So those are the kinds of things that we try and address with this project. That's kind of a strange hodgepodge of different things, but they're all based off of one principle, and the principle is if you know stuff, you can do stuff, right? Those are all about, I don't know what's going on in my environment. So that's fundamentally where we're at here, is discovering things that are going on in your environment and then doing things based on that. And that's the unifying theme behind all those seemingly random statistics. So I started this project. I was working on a supercomputer and it was not a normal supercomputer. It was a custom ASICs, 13,000 blades, 24 by 24 by 24, with 160 cores each. So this is 2.21 or something like that million cores. And I started thinking about scale in a way I hadn't thought about it in a while. You know, when you think about 2.2 million cores, that's a pretty good sized machine. This is a joint project between the NSA, I can tell you about this one because it's like in the public, NSA and University of Delaware and IBM. And it was all water-cooled. A lot of interesting stories about it. It was a cube computer, and the topology meant that normal ways of monitoring things would be horrible. Normally how a monitoring system works is, the guy in the center, I'm in the monitoring system, says, are you okay? How about you? Are you okay? How about you? Are you okay? And that kind of thing, if you were like in the corner of the cube and you went up over 24, back 24, and then the reverse path, you went through 144 system transitions to ask the question, are you okay? That's like that started making me think about monitoring in a different way, because the normal way of are you okay from one place clearly would be a bad idea in that environment, right? Clearly a bad idea. And so we've evolved from that, from this thinking about extreme scale and topology awareness, into now we discover topology and a lot of other things, and now it's sort of turned around the other way, and discovery is our main focus, and the monitoring is a side effect of a natural side effect of the discovery. We'll get to that and I'll explain how that goes in a bit. So I'm going to do 6 different things here, cover 6 different areas here. One is an overview of the software, a little about the basic technology, a little about best practice analysis, which is the stuff that's very much security related. Not necessarily security related, not exclusively, but that's our concentration in that. And I'll do a little demo. And if the demo gods smile upon me, it'll go well, and if not, well, it won't. And so, and then I'll talk a little about the current status and what I would like for you to do, you know, which is, this is more of I gave this same talk Saturday in Ohio, and it was an open source conference, so the emphasis is a little different, but the idea is there's still an call to action kind of thing at the end. What you choose to do, well, that's perhaps a little different thing in this audience, but that's okay. So we try and provide you insight on, we create a graph model. How many people are familiar with the term CMDB? Configuration Management Database. This is an ITIL kind of thing, and a lot of people say ITIL like they want to stick their finger down their throat, and you know, it isn't what they really want to do. But the idea of having a database that knows more about your systems than you do, that's a good idea. The thing that's the problem is creating it and keeping it up to date, and that's what we do here, and I think we do it well. But the idea is to reduce errors and speed up problem resolution, right? Reduce manual documentation, and because we know more about your systems than you do, why should you tell us how to configure things? We already know more than you do about how to configure them. You're running SSH on port 93? That's okay, we know that, right? And we know not only that it's port 93 and something's on it, we know it's SSH. So this is the kind of stuff we discover in our database that lets us do things that if you have this kind of detail that you wouldn't otherwise even think of doing, right? It's like if you had a manually created database, it's going to be wrong a lot, and so you're not going to actually do anything based on it, except maybe have meetings and discussions, which may be why people don't much care for ITIL and CMDBs. So we then drive automation in monitoring and improvements in security, and as I mentioned, this started out, the genesis of this was thinking about extreme scale, and of course everybody has a different idea of extreme scale, but I have a pretty high idea of extreme scale. Of what we think is here. Now, this pretty little picture here, so I usually describe this product as though it were four, and the reason why is because, remember I said it's kind of these diverse things we do, all based out of what you know. It's easier to explain as though it were four products than it is if you explain it as one. We cover the CMDB I mentioned. We then drive monitoring from that, monitoring of servers, monitoring of services. By the way, you should interrupt me if you have questions. Otherwise, you may fall asleep, not insufficient caffeine and too much blood in your caffeine stream or something. So don't hesitate. I am interruptible. Some people on the phone, not so much. In person, I'm pretty interruptible. So we drive monitoring of that, monitoring of servers and services. We also create a network map model, a network map. We know which NICs are connected, which ports on which switches. We discover that through LLDP or CDP if you know what those are. And the security aspects, for example, once we know what services are talking on the network, which we do, then I say, why don't we collect checksums of those things? And oh, by the way, how do the settings on those particular things compare with best practices? And so this is where we're at here. And there are sort of three different dimensions. The one universal thing I can talk to anybody who's in IT and I can say with a straight face, complexity is probably your biggest problem. I mean, everything else kind of tends to flow out of it's complex, right? And so what we try and do here is do two things that reduce your complexity and one thing that helps you manage the complexity we can't reduce. The two things we do to help you reduce complexity is we have one product which covers a lot of different areas instead of four products put together by shell scripts and Perl scripts and chewing gum and baling wire. So that it has a unified view of the world, and you don't have to then say, well, I have an inventory system and I have a monitoring system. I want to make sure I'm monitoring everything, and I have to audit it and check it by hand. We have all that information in one place. So there's a lot of things we can do on the basis of having that information in one place. And so that's one of the things we do that helps reduce complexity as opposed to separate products. The second thing we do, is it on this? Yeah, near zero configuration. I'm just doing it in a different order. My bifocals are playing tricks on me. The second thing we do is because of the fact we have all this information, it allows us to do a lot of things without any configuration at all, because we go look at your system and say, oh, well, this is how it ought to be. If you have an MySQL, I know how to monitor that. I'll just do it. So then that's the kind of things we can do to reduce the complexity, and how we help you manage it is by giving you an insight into what's actually going on. That's always up to date. That, if the better understanding you have, the complexity you have, the easier it is for you to manage. I didn't say we make it go away. I'm not going to say that, because it's not going away, but we can make some small dents in it, and we can help you manage the things we can't make dents in. And discovery drives everything, right? This discovery is very extensible. But since I think a lot of people here are, programmer at least some level. Basically, what you do is you write a script that spits out JSON describing whatever it is you want to discover. PAM rules, proxys, whatever, right? It's not hard to do. It's not rocket science, right? Except a few of those configuration files have really awful syntax, but most of them are pretty straightforward. A few of them are kind of awful. We discover systems, switches, services, dependencies, and we do it in a way that has no network footprint. So the nice thing about that is what that means. I didn't say for collecting the data. I mean, we discover it, and then of course we have to communicate it back. The communication back touches the network, but it's us talking to us. So we do have agents. I mean, that's the short answer. I see a little skeptical look or two around the room. We have agents, and that's the short answer of how that works. But I'll tell more about it in a bit. So we do it in a way that we should be able to. We have reason to believe our scaling should go up into kind of the 100,000 server range. Yeah, really. And I know that's kind of outrageous sounding. I'll get into that in a bit. And usually I have some tomatoes and eggs, that I pass out because sometimes people are a little skeptical. And the guy in the back, he told me they don't let you bring in rotten tomatoes and eggs anymore. So you can use those, but I forgot to pass them out. I'm sorry. No, I have actual tomato. I have stress ball tomatoes and eggs. And I just got running a little behind today. Discovery drives best practice analysis. And initially we're concentrating on security, but that's not our exclusive interest there. So I just made some claims. High scalability without complexity? Discovery without pings or port scans? Does that sound reasonable? Yeah, I see some raised eyebrows. Sometimes I ask people whether, my eyes are brown, and is that an indication of how full I am? And usually I get somebody nodding, yeah, I don't think that's you can do that, right? So let's talk about scalability. I can explain how we scale so that your grandmother would understand, even if your grandmother isn't Grace Hopper. And so it's very simple. That's, I think, one of the beautiful things about it. And I'll explain it to you this way, because this works with everyone. I've explained it to hairdressers, okay? I've explained it even to managers. I mean, you may have that hard to believe, but I've actually explained it to managers, marketing people, all these things. So it's very straightforward how it works. And I'll do this analogy, and I think it'll be perfectly clear. So at my church on Wednesday night, we get together for a meal. And while we get together for a meal, we stand around and hold hands like this, and in kind of a circle, and close our eyes, and the pastor prays over the food and whatnot, right? And while we're there standing there with our eyes closed and holding hands, if Aunt Sally passes out, who notices first? The two people holding her hands. Now, for you to participate in this human monitoring arrangement, how many hands do you have to have? 2. There are no trick questions here. The smarter the audience, the more they assume there's a trick question. It's like, no, I'm not going to answer that. It's like, no, that's too obvious. It's that simple. Everything is obvious here. So if I added 1,000 people to this arrangement, how many hands would you have to have? 2. Did your work go up because I added 1,000 people to this arrangement? No, your work didn't go up. Nobody's work went up. Everybody has the same work they did, and everybody has the same amount of work. And if you want to get literal, you could say, so we have our computers hold hands. And if you want to get literal about it, you could put your fingers on their wrists, and you could listen to their heartbeat. And that's what we do. We have the machines exchange heartbeats with neighbors. And sometimes people say, well, doesn't that mean it's going to get really slow when that, if you add all the people to it? And the answer is, well, if Aunt Sally passes out, are you going to whisper to the person next to you, like the telephone game, is there a doctor here? And going to wait for it to go on the ring? Or are you going to pick up the phone and call 911? Going to pick up the phone and call 911, and so do we. This analogy works way better than it ought to. It just works way better than it ought to. And, I didn't actually press the button. Oh, that's too bad, because this is the next. So this is I thought I pushed that button. Usually I do it a second or two in the thing. The point is that literally holding hands, you can see how this works. Everyone has held hands at one time or another. So if you prefer the computer science-y kind of explanation, I left my pointers in here, so I'll pull one out. He offered me one, but I turned him down and said, no, I've got several. And that's true, I do. See if this one's working, yeah. So the computer science-y kind of explanation is, machine A sends heartbeats to F and B, F sends them to A and E, E sends to F and D, and so on. I think this is pretty clear, right? And so imagine A fails, then F and B are going to report that it's dead. So every time machine dies, you get an even number of reports. Now, 2 in this case. There are other cases where you might get a different number than 2, but this is the case for this implementation. And this is what the code currently does. And so if A dies, then we splice it out of the ring using linked list manipulation techniques. I think most of people here probably have an idea what that's like. And it's not rocket science. This is in Knuth Volume 1 and has been since I was in college. That was a long time ago. And so another technique, so I thought about, well, what would it be like for it to be, if it were topology aware, what would that look like? And that's what this diagram is. And I don't know if I'm going to get out of his camera or not, but I'll stand over here anyway. So this is one we would like to do. This is not what we're currently doing, but it's really cool. So I'll explain it to you anyway. So imagine that you had a ring per switch, and that this was a switch, and this was a switch, and this was a switch, and those were the servers on the switch, right? And then you had these machines as neighbors. This guy's neighbors are this one and this one, right? So the problem with the wonderful thing about that is your cheapest and most reliable bandwidth is within a switch, right? That if it breaks, then the switch is broke, right? Pretty much. Not always. Sometimes switches do weird things like one port can't talk to another. Firewalls, other things can interfere with it. But for the most part, this is a really good plan, except if the switch fails. Now, there's an old Harlan Ellison science fiction story called I Have No Mouth and I Must Scream. And of course, you can't scream. So instead, we create a second ring, one per switch, nominate one machine per switch on a subnet. And now this guy has 4 peers. This one, this one, this one, and this one up here, right? So now if he dies, you get 4 reports. This is why I said an even number earlier. You get 4 reports. Now, the interesting thing happens is, what if the switch dies? How many reports do you get if your switch dies? Don't see if you're awake. Come on, see if you're awake. How many reports? 2. So isn't that interesting? Isn't that interesting that you get 2 reports if the switch dies, and 4 reports if the server dies? Now, the question I ask you is, does it matter what kind of switch you have for this? I don't even know what kind of switch it is. It's just I know what the topology is. I know who belongs to the switch, and you can find that out by LLDP or CDP. So, and then imagine that you had one ring per subnet across a site, and imagine a little farther, imagine you had a lot of sites. You could have another ring, 1 machine per site. You have too many things on the picture if you have sites, and not only that, I didn't think of it after I drew this. This was a pain to draw, and I'm not drawing it again. So you get the idea, though, and the interesting thing then is you could have tens of thousands or hundreds of thousands of servers across a great many sites, and almost no traffic between sites. This property, if you look at it here, if you have 48 machines on a switch, 48 machines on a switch, that means about 95% of your traffic still stays within a switch. So it's almost invisible in the network. This is almost invisible in the network. Now, the other thing, too, is because we've delegated it this way, it's, we just sit back and wait for the phone to ring. So let's look at the scalability back of the envelope style, right? So imagine you had 10,000 failures in a day. How many admins would you have to be running around to fix those? A lot. More than 10,000 by the time you count them and their bosses and the HR and all the other bureaucracy and everything. So you have a big organization, right? A very big organization doing nothing but managing these servers. And how many people think that would be a headache to manage and run, that human side, right? So for me to manage the computer side, for me to pass, how many people think handling 10,000 packets a day, or even 50,000, it takes 5 to repair the ring, a day is a problem? Exactly. That's why it scales like it does. Because you run into other problems that you spend all your time on long before you hit a scalability limit here on this. Does that make sense? Is this making sense? This is way cool. I mean, this is way cool. It really is. Other people tell me that too, so I feel free to say it. For monitoring, I use basically the same techniques we used in Linux HA. We delegate the monitoring to the machine itself. So for example, if you have a web server, we have an agent on there which asks the web server, does a wget or an HTTP, an HTTP get every so often on the machine itself. So it's the same work you would have done across the network, except you're doing it in the machine, and so you're not touching the network to do it. Now, you want to also make sure the machine is connected, and you want to do other things as well. But for the general rule, that's what you want to do. It's the same work you would have been doing, except it's happening on the machine itself. And if you do this right, you can do it in much less CPU effort, or no more at least, than it would be to do it externally. Right? You can actually probably do it more often because you're not touching the network. And doing an HTTP GET on the server is the same, regardless of whether it comes from 127.0.0.1 or some other address, right? Doesn't make any difference. So we currently use the Open Cluster Framework, and Nagios is actually here. It says coming, it's actually here. I should have updated the slide. We can also talk Nagios agents. Nagios agents can talk to us, I should say. And they're perfectly happy to. The Nagios Remote blah blah API, I forgot what it's called. Whatever it is, I read about it and I implemented it. I don't remember the name. So here's how we do discovery. I mentioned this already. Basically, just like we do the monitoring, every so often we run a script and it tells us whether things are up or down. Now with the JSON, with Discovery, we every so often run a script. Instead of spitting out an exit code, it spits out JSON. And then locally we'll look and see, is that the same JSON it gave us last time? If it is, we throw it away. So how many people like to leave their systems alone once they get them working? So yeah, exactly. Everybody likes to leave their systems alone. This works greatly in my favor because that means the JSON's almost always the same. So this is working. You see how this works in my favor scalability-wise, right? So we store it in the Neo4j graph database, and in some cases, depending on exactly what it is, we respond to it when we receive it. Sometimes we just store it. Sometimes we do something with it, right? Depends. Sometimes it's like, I just want it there, so if you query it, you can use it. And sometimes you want to actually trigger other actions based on it. For example, I don't change. The first thing it does is give your network interfaces, and the second thing it does is tell you what kind of operating system it is. I don't trigger different actions based on the operating system. It affects the other actions which are triggered later. It's sort of the other way around. It's like, I don't do anything because first of all, it never changes while you're up. So here's an example of what the JSON looks like for, this is the operating system, the OS script. Tells you it produces JSON that says the node name is this, the operating system is this, the machine. This looks like, for those of you who know, this looks remarkably like the long flags on uname. They are exactly the same as the flags on uname. It makes the script 30 lines long. And these are the flag names on LSB release, okay? You guys don't probably use Ubuntu, but I'm always confused by the code names raring and this and that versus the version numbers, and I can never keep them straight, so I made sure I got this stuff in here to help me remember these things. So you maybe don't care about code names, but knowing the exact version number of the operating system, not of the kernel, right, of the operating system. This works for Red Hat and so on as well. And distributor ID in your case might say CentOS, or it might say scientific, right? Same idea. And here's what it looks like for an SSH, the SSH daemon. So we also discover, this is how remember I said we don't send packets over the network? Well, if you do netstat, I don't have to send any packets over the network. If I'm on the machine and you let me be root, man, I can find anything out. I can find out way more than you can over the network. Yeah, you have to be root to discover some of this stuff. Some of the stuff, it's... And when you get done, we have a database that is the buried treasure map to your site. Bad guys who wanted to break in would love to have a copy of that because it would tell them exactly where to go and what attacks to use and what's going to work. So that's the downside of providing useful information. I can't provide useful information and have it not be useful in the wrong hands. That's just kind of how it is, right? So actually the format has changed a little bit. Notice that though that I know exactly what binary is, exactly what arguments, user ID, group ID, what its current directory is, and what addresses and ports it's listening on. So this is how I know that this is SSH when I go to say, oh, that's SSH, so I can monitor it with the Nagios SSHD thing, right? Nagios, whatever the Nagios script is, right? You basically have a little pattern, regular expressions based on this stuff, and then you say, when you find that, then plug that into this script in this way, in the arguments of this script in that way. It's 10 or 15 lines of JSON. It looks a lot like the other JSON for the other ones, except a little bit different, of course. And then conversely, this is what it looks like on the client side to say that I have a connection placed right now. Now, SSH was easy to set up and demonstrate, but bad from the perspective of, this could wind up creating. We need to have some filtering on this that we don't yet have in terms of deciding what to keep and what not to keep. SSH is probably not typically a good thing to keep, but it makes a really good example. So in this case, I'm SSHing to a machine called Servidor, and I'm connected to 10.10.10.5, which this guy's listening on any, right? So he's going to be the one that's connected to that. So when you put these together in the same graph database, one guy's saying I'm providing this service, another guy's saying I'm using this service, and you put them in the same graph database, now you have a dependency that looks kind of like this. So here we have an SSH, which is connected to 10.10.10.5 port 22. This guy here, SSHD, is listening on this port on 22 and listening on this port on 22. So now you have a dependency between the SSH and the SSHD. It just happens because we do netstats every so often. Now, if you have a service that, for example, comes up and it runs for 100 milliseconds every quarter, it'll be a very long time before we see that particular client side. We'll see the server side all the time. The client side we won't see. So this is actually from a graph at my house. This is real data taken from the, this is not created by hand. I wrote a Python program to extract it out of the database and make it pretty, but this I didn't create this by hand. I created it out of the data from running real. Oh, heck, yeah. Another thing I forgot to pass out. I have a graph, a sacred scroll like this long that's 4 machines at my house. That's the rest of this graph. So here's what it looks like when you, the switch side. So here we have this machine, which is my now defunct laptop, and a machine down in the basement. This guy has the NIC ETH0 at this MAC address, and this switch down here has port G3 or switch port 3, which has this MAC address. And in the switch, it's labeled kitchen north wall white jack. So I had to tell the switch that, but I didn't tell my software that. The switch told my software. And so I put that in the database, and now I have a wired to relationship that says that this guy is plugged into the kitchen right now on the north wall into the white jack. Now, of course, this could be wrong, but the G3, that's not wrong. It's plugged in port 3. That's not wrong. The label could be wrong. It is documentation, after all. But we reflect that through our graph when we see it. We also get other stuff like the MTU and the duplex on both sides of the link. So now, anybody ever seen a duplex problem where two machines weren't talking together right because the duplex was mismatched? Oh, wouldn't it be nice to get an alert that says these two machines have mismatched duplex? The alert isn't there, but all the data is. You know, it's sort of crawl, walk, run. And we keep that up to date. Now, of course, I will mention, you talked about virtual machines. Virtual machines don't usually show us all this data. This is when you're on bare metal or have CDP or LLDP packets are coming through to us by whatever mechanism. I don't care how they got there. I want it to be right, but I don't care how they got there. Mostly virtual machines don't push them through. But this is pretty cool. Anybody ever heard of anybody going to the wiring closet and getting a mistake on which one is which and which server is on which port? I know that never happens here. Exactly, never happens here. So where I used to work, it used to happen all the time. And wouldn't it be nice to have a tablet? Another example of an application I haven't written, a tablet app that draws a photograph of your port, and then you click on it and it says exactly which machine's behind that, what services are on it, because we know, and what services depend on those services, because it's a graph database, we also know that. So, once you know stuff, you can do stuff. You begin to see what I mean by that, right? I can't even say what all the possibilities are. I have no idea. But I know that they're significant and very, very great, right? So we use a graph database, and this is why. You may have read all of this by now. You may not have. For those of you who are still awake anyway. So humans describe systems as graphs. Anybody ever had a technical discussion about your networks or your computers, right? Somebody goes to the board and picks up a marker, and they draw circles and squares and arrows, right? That's a graph. This is a graph. It just happens to be a graph with a lot more pieces and parts in it because whereas you and I can sleazy ignore a lot of detail, you can't really do that in the computer. You wind up in trouble. So it's a lot more detailed than what you and I would draw, but it's the same idea. It's the same thing. So it thinks. Anybody ever have trouble thinking the same way a certain program thinks? It usually works better when the program thinks like you do. And this is as close to how people think, or at least how they communicate with each other about their systems. That's one of the reasons I like it. Of course, the dependency information is obviously a graph. You could argue that all of the really most interesting questions about data centers are graph theoretic. Like, for example, what all depends upon this directly or indirectly. Another example you might not have thought of. You ever have a cascading failure where this thing goes down and it takes a bunch of other things down with it? So one thing to know about logs is the fact that they come out in the log in a certain order doesn't mean they happened in that order. Because things happen at a certain time and they're observed at some time later. And then then of course you use, especially using UDP, some log entries get lost, other things like that, right? So how about a query that says, I had this bunch of machines that went down. Tell me which one of those machines doesn't depend on any of the others in that set. That's your patient zero to start looking. It may not be the right answer, but it's where to start looking for what the cause of that cascading failure is. Does that make sense? Graphs are cool for this. They're really cool. Visualization, of course, is natural. Root cause queries, that's what this is, right? One of the interesting things, too, is the speed of graph traversal does not depend upon the size of the total graph. It depends on the size of the subgraph you want to traverse. Graph databases are like pointers in C in memory. They just have pointers to the next thing. So there's an index outside, for example, it might help you find a machine named, I don't know what's the machine's name, Ubuntu 72, right? Oh, no, that's not the machine. This one's named System 76. So you might have to go through the index to enter the graph, but once you find it, you're following the graph pointers. And so the speed of that depends only on the number of machines you have to touch, not on the size of the total graph. So whereas in the relational database, whenever to do the same kind of things, you go back and do a join and a join and a join and a join. And every time you do, you go back to the index, and the indexes get slower based on the number of systems that are in your system. So for things, because most of the time, you don't have, every system does not depend upon every system, right? They mostly have cliques of machines that go together, and this clique of machines goes together. And a large clique of machines might be 500 or 1,000. Well, that's not that many when compared to, indexes, maybe I don't know how many machines you guys have, but it's tens of thousands, right? Hundreds of thousands, perhaps, right? It's clearly, over the whole universe of machines you guys are responsible for, it's a lot. And so from a scalability perspective, that's an interesting piece of, by the way, not every graph database has that property. Titan doesn't because it uses indexes for everything, but Neo4j does. Visualization is natural. We haven't done it, but you've seen some of the visualization I've done, right? It's not. When I pass out the scroll that I forgot to pass out, you'll see the one for my house, and it's this big, and it has all kinds of stuff on it, and it's kind of small print. And so I know already how to create a graph that will terrify you. What I haven't yet figured out is, I haven't sat down and thought about it long enough how to do a good job of providing the insight, the aha, without the terrify part. Just because it's complicated, right? If I provide you a graph of 1,000 machines on one sheet of paper, it's like, well, what am I supposed to do with this? It's not so obvious. You have to filter the right stuff. And you have to do things like, here's my machine of interest. I want to see the things that depends upon the things depend upon it, and restrict your view to that. Well, that's more complicated. It can be done. It probably will be done, but it hasn't been done. I'm a fan of solving problems that you know how to solve well, and then thinking about the others until either you really have to solve them, or until you figure out how to do them well. Because I've got plenty to do. It's not like I lack for stuff to do, as you can see here, what the potential of this is, right? Schemaless designs are good for constantly changing heterogeneous environments. So, for example, if you had all the attributes of your switches, and all the attributes of all your different switches in there, and you had a schema for it, and then you got a new switch in, and you had to change the schema to accommodate the new information about the new switch, you'd be constantly shutting your database down, restructuring it, and starting back up. In a schemaless graph, it's like, yeah, we'll just stick it in there, man. We're all good. And that just works, right? So it's a little bit, that's not just Neo4j, and that's not just graph databases, but schemaless is nice when you talk about the constantly changing heterogeneous nature that a data center is, right? It isn't a problem it's kind of squishy. It's kind of squishy. Things keep changing. About the time you figure something out, it's now obsolete. As a guy who's been obsolete many, many times, I can assure you that's the case. And from the perspective of writing the code, my graph model is my object model. It's kind of like having an object database with relationships, right? And my objects are, when I just modify my objects, when I get done, I say, commit that transaction. And it's kind of nice. It's kind of cute from that perspective. So here's a few canned queries. I'll go over a couple of them, and this is because these will show up in the demo. Tell me all the IP ports on every machine, right? Every IP and every service on every machine. Tell me the machines that are currently in a crash state. Tell me all the machines which have been gracefully shut down. Tell me all the machines which are down for any reason. Tell me all the IP addresses that I don't know what they are. And that also brings we also know the MAC addresses as well, in most cases. Tell me all the services that are. I'm sorry. Tell me all the services that we're not monitoring. So this is a query, right? So that if you want to close that loop of I want to make sure I'm monitoring everything, so that when things happen, I can diagnose them more rapidly, right? Run the unmonitored query every so often and figure out what it is you're missing. Things will not be monitored if we don't know how to monitor them, or you don't have the agent we need on the machine. You have to teach us how to monitor something. I'm sure you've got applications I've never heard of, right? And I don't know how to monitor those. That's not my problem. You provide that. You provide the thing which helps us recognize it when we see it, and then from then on it gets monitored.
Yeah, no.
So we want to be on all the servers, of course. But so what? So today we're not doing that. A lot of the API, a lot of the agents we use are capable of doing the monitoring over the network, but so we haven't done that at this point in time. We actually can tell you about the IP addresses. We could do more, but again, those things tend to. I'm trying to concentrate initially on what we do really well and get that out, get that deployed, get feedback, get people to say which things you really want to monitor and understand what the impact on you is, and have conversations around that based on reality as opposed to what's going on in my head, which is nobody cares what I think. My wife doesn't care what I think, and you guys don't probably care much what I think. What matters to me is what matters to you. So we deploy this, let's say, and you have all the machines that agents are not on. You come back and say, what can we do about these machines? We can talk about what kind they are, what kind of services they are, and we can work out a solution to it. It's not that you can't do it. I mean, let's imagine you have this on 1,000 machines in your building. I have 1,000 machines that I can recruit to help me in that process. I mean, if you're willing, they're possible, because I have agents on them. I don't have to do this from the central machine. I can delegate that work just like I do everything else. Now, whether it's a good idea or a bad idea, or there's some machines you don't want me to do it on, that's all good. We haven't done it, right? That's one of the reasons not to do it, is because I want to understand what the constraints are on a solution that would work for people who are actually using it. Does that make sense? Because the easiest thing in the world is to make up problems that you don't have and try and solve them in a vacuum. And usually in the end, you waste a lot of effort, time, you frustrate people, you annoy people. They thought you solved the problem and you didn't understand it. I don't understand the problem well enough yet. If you guys want to deploy this and help me understand your problem, that's why I'm here, right? So you get the idea of what these are. These are canned queries. Best practice analysis. We'll talk about this some more, and I'll give you some examples. Basically, whenever we have discovery update, if one of the kinds of discovery has rules associated with it, for example, /proc/sys, PAM settings, etc login.defs, other things like that, sudoers. If those have rules associated with some particular piece of discovery information, then when it changes at that point in time, we trigger the analysis of whether we're in compliance with those rules or not. And then we tell you if you broke any new rules or fixed any old rules that you broke before. Basically, did you make it better or worse, or is it the same, right? And the advantage of that is that instead of waiting for your security people to come down and yell at you and you're scrambling around trying to figure out what you're going to do about all the stuff, bad things that happened, or the auditors come around next week and you have to scramble to get it all fixed before they show up. Instead, which might be 6 months, a year, 2 years after the person made the mistake which did this. Instead, within a few minutes after they made the change, you're aware of this, and you can sit down and say, what was up with that? Why did you do that? And you have the opportunity to have adult conversations, as opposed to the the high drama things that happen under the other circumstances. Now you can sit down and the security guy can say, well, we have this rule, and you violated it, and let's understand why you did that. Oh, I didn't know it was a problem. I can change it. Or they say, no, this machine's different, and when I have that, I can't perform the function I need to perform. And then you can make an exception. And you can have that conversation right when it happens, not months later. After someone's left, after someone has forgotten about what they did, at 2 in the morning when they tried to fix some other problem. Anybody ever experiment on a machine trying to fix something and back it out? What if you experimented on something and forgot to back it out, and it was kind of a violation of a rule and you forgot to back it out? Well, the next day it's going to show up in your log, and you're going to know. Now, it will only catch the things that you broke a constraint, right? Most things aren't constrained, but some things are. And so if it's important and you have a constraint on it, you'll know. As a developer, I forget to back out. I always do, a get diff before I commit, because it's like, oh, there's like stuff I put in there that really doesn't belong in the code. Got to get rid of that. It happens. It happened. For 10 years, I did system administration, and I had the same thing there. It happens. You try and solve a problem. You think, I think it's this, and you're wrong. Now, if you're right all the time, that's different. I'm just usually not right all the time. So here's a few. These aren't very interesting. It's like security patch coverage, other operating system settings, application settings, and I want to go. The Linux Foundation has expressed interest in what we're doing here as well. We have another project associated with this called the called the IT Best Practices Initiative, right? And that the purpose of that is to collect these best practices in a Git repository, and have them available for anybody to use either with a tool, their own tool, or manually. And I seeded them with some of the DISA specs to get started, although I called them NIST specs, and there are people who slapped my hands and told me that I was wrong. They're not NIST specs, they're DISA specs, so I need to fix that. But the NSA hardening guides are the DISA specs. That's exactly what they are. And I'm going to demonstrate those in a few minutes. And you'll see that about 60% of them fail on an Ubuntu machine, the stock Ubuntu machine. It's pretty close to the same for most of them. It's about half of the machines, about half of the rules pass, about half of them don't on a stock machine. Now, some of the rules are silly, like you have to turn off IPv6. Like, I don't live in a world where I think that makes much sense. Maybe you do, but if you don't need it, you can turn it off. Although I think my software might whine because I think of everything as IPv6. All IPv4 addresses are actually IPv6 because it gives me a uniform way of thinking about things. And then I can't accidentally make it not work with IPv6. So I haven't actually tried to turn off IPv6. I'm afraid that if you do, my software might not work. I don't know. So there's another project which also does something similar, has some open source hardening rules as well, the Linus project. Linux Foundation has expressed interest. Their security, the gal who's in charge of the security is a gal I used to work with at IBM, and she's very interested. In fact, she wrote some Python code to let you query about these things, right, and bring them up in a web browser. So these are checksum outlier analysis or something. Let's go to the demo. We'll talk a little about the IP best practices.info. I kind of implied that. But the idea of it is we're not actually creating code to check these things. We're creating the code which describes them, the text which describes them. And that's pretty much exactly what the DISA rules are. And the reason for not doing the code is because different people's implementation, that implies a lot of infrastructure to surround this. That, for example, if I made it suit myself, which would be my desire, it wouldn't work for anybody else because they don't represent it all in JSON and stuff like that. So you'll see why I do that. I'll show you that in a minute here. Curate mechanically verifiable processes and human readable descriptions. One of the things about the DISA rules, which you guys don't care about, people in the world do, is they're English only. There is no provision for other languages. So mine has the same rules, but with provisions for translations. So here's an example of a short description of one of these. System must limit the ability of processes to have, this is the short description, simultaneous write and execute access to memory. In other words, you can't have modifiable code. This is to stop you from being able to do buffer overruns, right? And the long description is this. Blah, 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 blah. And then here is the how to check to see if, this is actually from the DISA stuff. This is how to check to see if this is, to see if you have this condition, how to manually verify this. And here is my piece of code, which I have to put in here to tell me whether this is true or not. So this is easy. The text is actually quite hard. It's the communication to people, because I can tell them, did you realize you violated NIST B38597? What's up with that? And they say, what's that? And, well, it's you gotta conform, man. And that doesn't work. Anybody ever say you've broken a rule, you don't know what it is, and don't understand why, and don't know what the impact is? That's the purpose of the text. And in a lot of ways, that's the most important part, because if I tell you violated something and don't help you understand it, you're gonna start ignoring all the rules, because you don't know which ones apply to you, which ones you have to violate, which ones you don't. I mean, maybe you have one application on one machine which really has to write self-modified code. That's how it works, and you can't change it. You bought it, and that's how it works. Or everyone's afraid to touch it. Anybody have an application they're afraid to touch? So you're afraid to touch it, and it has self-modified code, and when you turn this on, it breaks. So you have to turn it back off. Well, you want to understand what it is. You want to. I don't think this one does an especially good job explaining to you the impact of it. If it had said something like this helps prevent, a buffer overrun attacks, then that would have helped, right? But they didn't say that. We can always add that, but it's long as it is now. It's hard to understand as it is. This is the hard part, honestly, and this is the part everybody can agree on, right? We could disagree about the code, but everybody can agree what the problem. We can come to some consensus on it. We can come up with text that's good enough on all of these things. And I don't want to restrict myself to the DISA specs. I mean, obviously you guys are concerned about those, and you should, but I'm concerned about what you should be doing, and that's probably the DISA specs plus some, right? Because if all you're doing, if it's just a box to check, if that's how you're approaching security, just to check the box, then you're not. That may be enough for you, right? But it may not be. If you're really concerned about the impact of security, you want to understand all the things you should be doing, and that's the minimum, right? The minimum is to get to the point you can check the box. Oh, and here's the demo, which is coming up, and I haven't looked to see if I've gotten an IP address. The demo won't work if I don't have an IP address because the code doesn't know what to do if it can't get an IP address. It has to have an IP address. So I plugged in, and I assume I have an IP address, but I haven't checked, so we might have to do something to do that. So anyway, we're going to do the discovery-driven monitoring. We're going to monitor things we've discovered. We're going to compute checksums on things that we discovered. Monitor. I'm probably not going to do failures and successes because I don't remember what's on this machine, exactly what things. We do host down notification with best practice rules. I didn't supply any configuration. I didn't even tell it where the central server is. The central server happens to be on my laptop, but it doesn't know that. It doesn't matter where it is. Now, in your environment, what I'm doing here wouldn't work. I went to IANA and got a reserved multicast address. And I just use that to locate the central server. It sends out one multicast packet, and the central server sends back a unicast, says, here I am. It's just a very convenient way to get started and help you do experiments. But if you have an environment where multicast won't span across your environment, you can't use that. You have to tell it where the central server is. That's not a terrible thing, but you do have. But I like things to be as easy as possible because you can't. Yeah, question. I apologize. I'm running a little late here. Yes. No, they're not configured. That's not a configuration thing. Well, when a machine wakes up, it doesn't know anything. It wakes up and locates the central server. Either you tell it or it multicasts, right? And then the central server said, here's your neighbors. It picks two. Doesn't matter. I mean, I actually have the code has 2 pointers for a place in the ring where I'll split them apart and put the next guy in. It's linked list manipulation, right? And it's a circular list, and it doesn't matter where you put them in the ring, except you don't want to keep hitting the same guy as a neighbor over and over again because you're giving him extra work, and why would you do that? So we actually kind of move it around the ring, and the insert point moves around the ring as we add people. So we already have to talk. We want to know they came up. They already have to talk to them. We're going to tell them a whole bunch of stuff to do. I've really taken more time here than I should have on this. I'm sorry, I wasn't checking. Well, that's important. Grab a lemon on the way out. Oh yeah, right. This is the right thing. So let's do an IF config and see if I have an address first. E0 has an address. I don't care what it is. I just have to have an address, so the software goes nuts. I mean, it doesn't go nuts. It just doesn't know what to do. So now I'll do a demo, and I have this script that I've cleverly named demo. And when I run it, let me do a tput clear first. I'll have to stand out here and tell you what it's. Oh, yeah, that too. It's going to start the CMA. Oh, I'm in the wrong directory. Sorry. What directory am I in? Apparently, my demo wants me to be in that particular directory. Tput clear. Remarkably hard to look that way and type here. So we're starting up, and the central better. So we started up here, and now it's going to start a nanoprobe. And closing connection really means it's restarting the connection, and it's off doing some discovery with it. Now the results of that will start showing up here in a few seconds. And we just have a little stuff here about what's going on here in terms of versions and stuff like that. And now we're off, as I said, off doing some discovery. And here we go. We've gotten back stuff from etsy login defs, and we have failed 1, 2, 3, 4 rules and passed 2. The encryption method is set to SHA 512, but the UMask is not set 077. Did that kind of make sense at least a little bit? I'm sorry, it'll stop here in a minute, and I'll point out some of the ones that won't keep moving. And so that was the ones on different things. This is on procsys, a whole lot of things on procsys. 25 rules or something like that, maybe. So this one's a networking rule, not a security rule, okay? Anybody ever heard of buffer bloat? So we have a best practice rule that says you should set your machine up so it doesn't do buffer bloat, which is buffer bloat is a bad thing. You don't want to do it. Now I did that for a couple of reasons, because I read about buffer bloat and I thought it would be cool to have a rule. And second of all, it's an example of a rule that isn't security related. And our mechanism, we don't care if it's a security rule or a networking rule. We know, but we don't care. You care, so we tell you. So we've done some stuff here. Processing checksum data. What went off the screen here you didn't see is it said it's collecting checksum data from 83 files, but it's processing checksum data from 121 files. So the interesting thing about 83 files is about a dozen of those that are hardwired. There are things like bin login, bin shell, bin password, things like that you really want to be the same. And everything else is discovered, and it's discovered on the basis of what things are talking on the network, either client or server. And then in addition to the things that are talking on the network, client and server, then it also looks at the arguments to Java programs and picks the jars out of the class path on the command line. And it takes all that together and says, go discover the checksums on those 83 files. But it gave me back 121 answers. And the reason why it did is on all the files, it did an LDD to say, okay, what libraries are you linked against? Let's do checksums on them too. So without configuring anything, we have the checksums of everything that's talking on the network. Now, it doesn't catch everything, but it catches all the stuff that your bad guys are going to want to corrupt. Almost everything. And by the way, we also catch all the checksum programs too. Do the checksums on the checksum programs. So let's go here, and we'll look at some of these, right? We passed the TCP SYN cookies has to be 1. Here are some. We discovered this service Neo4j is now operational. So earlier it said I discovered Neo4j is a service, and I'm going to start monitoring. That scrolled off the screen. But you look here, you see it now. It's up. It's up. It's up. It's up. Now the check load is not a service. That's just checking to see if your load average has gone off the top. We have some defaults on that. And basically, the defaults are intended to mean if you trip our alarm, you're in bad trouble. You can make it less. You can make it more conservative. But I think a lot of people set these things too low. They think, oh, I don't want to actually use my computers. Like, I have a computer. I want it to run 100%, actually. What I don't want to do is have it not do the things it needs to do in a timely fashion. That's a different matter. CPU busy is not really relevant to that. How many people are waiting on the CPU? That's interesting, and that's what load average is about. So it also does check SSH, and again, in the case of check SSH, I've tested it, and actually, no matter what port SSH is running on, it gives Nagios check SSH script the parameters to tell it which port you're on. And it does this for everything. Because we've discovered the ports it's on. We know the command line options it was given. If there's some command line options we need to use to provide to the agent, we have all that stuff. It's all there. And so this is debug stuff really. But what's in the system log? So we failed the security rule, blah 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 blah, and it gives you a URL which is itbestpractices.info with some stuff that if we had this deployed, if we actually had her web server up, which she's written, up and running, and aligned the port numbers and got my text just right, then if you clicked on that, you would go and get an English description of all that stuff I just described. You know, the stuff I had up on the screen before, the short description, long description, all that stuff. And the idea is that we'd like to do is have the browser look at what languages you had and see whether we offer it in that language and provide you that stuff too. But that hasn't been done. And if you want to write a program that does the same thing, goes after that particular item, there's a slightly different one that will give you the JSON directly. not a web page, but just the JSON of everything. So you can provide your own user interface and not through ours on the web. Maybe you think ours is ugly. Maybe you want to integrate it into yours. It's all good. We don't care. That's so let's do a command. Let's do a query here. Let's do ASSIM CLI query. And if I say list, there's a query whose name is list. That's the list of all the queries. And that's just a query list. It's not a usage command. It actually the queries actually have database elements. It actually does the query in the database. That's a built-in query called list. And so let's go look at unmonitored. Right? So that's a good one. Let's do unmonitored. What happened here? I thought Control C. Oh, I know what happened. It's saying here, I'm offering a service I'm not monitoring. What service is it? It's Dropbox. I mean, I suppose I could monitor Dropbox, but it tends to go up and down based on the user and all this stuff. But it also makes the query produce an answer, and you get the idea of what it does. I didn't tell it what services I had. I didn't tell it what ones I monitored. It knows what it's monitoring, and it knows what services I'm offering. And when I said no configuration, that's pretty much no configuration. You saw all the stuff it did. And if I, you always hate to try queries you've not tried recently in a demo, don't you? I don't know if I'll get any. We'll find out. Yeah, we did. So this one is one I've gotten through an ARP. Anybody? How many people here know what how the ARP protocol works, kind of? So we listen to ARP broadcasts. If you have one machine on every subnet, we eventually get all the IP addresses and all the MAC addresses of everything on every subnet, right? As sometimes I say, my mama always told me it's amazing what you can learn just by listening. So we listen to LLDP, we listen to CDP, we listen to ARP. We listen to things that we're permitted to listen to and nothing else. We don't intercept traffic, application traffic. I don't want to go there. You have to have a lot more trust on me and my code than you would for listening to ARP and LLDP and CDP. Those are pretty harmless. And somewhere here here it is. It means it doesn't know how. I don't have a rule that tells it how to monitor Dropbox. I thought about writing one, but then I wouldn't have anything to show you in this query. There are disadvantages to covering everything, So we have the number of things we currently have rules for is smallish. The point is, if you put it up and you say, look, I want you to do this, we'll sit down and do it. It's not, so if there's already an agent that knows how to monitor it, then the rule to tell it how to there's two pieces. One is you have to have a script that knows how to monitor SSH, right? And that's already written. And then you also have to write a little rule that has regular expressions on the stuff we've discovered that says when the base name of the binary name ends in SSHD, and the user ID is root, and whatever it is you want to do, then, or maybe you want to do a full path name on it, whatever you want to do, then here's the rule you use to monitor it with. So that's not hard to do. You write a couple of regular expressions, and then you tell it how to fill in the parameters for the kind of monitoring you're doing based on what it's discovered. For example, in the case of SSH, I have a rule which picks out of there the port. I've also discovered the port that it's running on, so I plug that in. I think there's a -p option, so I put -p in whatever port it discovered, and stuff like that. And so there's a little language it's all function calls, right? I didn't do anything fancy. It's just function calls. If you want to have an if, we could have an if. We have an and an or and stuff like that as function calls, right? The if function, right? So thanks for coming. Grab something to eat or drink on the way out. So all switch ports tells me every port that's connected to every port that I know about, every switch port I know about, and every host port that it's connected to. And the host switch ports tells me all the ones on a particular host. I have no idea if the LLDP or CDP are enabled on this network, but we can run it. What was the name again? It was all switch ports, right? I don't have to type anything else if I do this one. Look at that. I'll be damned. Must be LLDP because I'm pretty sure my CDP code is broken. This is the description, and it has new lines in it. Sorry, it just does. That's how it came out. So I've never been in this. I've been in this building before, but I have never plugged in your network. I did not have any idea this was going to work. Most of the time I'm on a wireless, and the wireless you usually don't get LLDP or CDP. So it worked. So it says that I'm on. Yeah, but it tells me which port somewhere, right? E0 goes, right, port 47. Yes, I assume that's port 47. No, maybe that's the somewhere on here is the port. Whatever you say. Oh, right. Yeah, right. Port 27. So, is that cool? And you can plug me in a different one, and then we can do it again. Okay? So, this is a piece of documentation that you don't have to maintain then. For the places that you have, if you can run it on the bare metal machines, right? If you're running VMware, for example, VMware will most probably not let me see these packets. There may be a way to allow you to do that. I'm not a VMware expert, so somebody else who is can go talk to VMware. I actually have friends who work there who could probably help me answer that question, but I've not tried to answer that question yet. That's so awesome. Oh, it's interesting. It says LLDP invalid because required TOV type 1 isn't in the right position. I don't know what that means, but apparently it. Oh, it's CDP. Oh, yeah. I'm getting CDP packets too. Yeah, this is. I told you the CDP code's busted. It's there, but I don't have a CDP switch at home, so I haven't. You have both. It looks like you have both enabled here on the same switch, and I can tell you that's probably going to confuse my software. Well, that's a solvable problem, right? But damn, it worked. Yeah, what a surprise. Yeah. And LLDP is, some people won't turn on CDP because of its history of, it used to be you could actually make changes to the switch through CDP, like CDP version 1 or something. And so it has it's like some people say, no, CDP is insecure. I don't know whether it is today or not, but I have heard that it used to be, and that seems to be a pretty consistent story. So LLDP by design is designed to not be able to, LLDP, you can't do anything to solicit a packet. You can't do anything to change the packet you get ever. So that's pretty hard to break into, right? If the guy you're sending packets to is not going to listen to you, it's pretty hard to get rid of. So thanks for coming. By the way, I do have stickers too. You like stickers? Here, have a sticker. I got some right here. I have all kinds of stuff I've got. That's because I had to hike up the hill with all this stuff and got my shirt absolutely soaked in sweat. Fortunately, I was planning on changing shirts. Yeah, the graph is here. Yeah. I don't have a program to display it. Remember I said I don't have the GUI? Yes, the graph is there. I actually do have a shell script. The Python script that generated these. Here. I'll give you your own, and I'll pass the others. Told you there's scrolls. I wasn't joking. Here. These are. This is my house as of a year or two ago. Pass it when you get done. Pass it around. Here. Oh yeah, right. Of course. So, yeah. And if I had the program that I used demonstrate this on this machine, and we screwed around enough, and I messed around with it, and I fixed it after I'd broken it because I've changed stuff, then yeah, we could generate a graph like this. The graph is there. So the thing is, if I have it, it's in the graph. If I don't have it, it's not in the graph. It's all the same. They're all the same. So that's real. And that was all discovered with no configuration. Do you see how when you listen to stuff like this, you can do things without configuring them? Anybody think this is cool besides me? This is real cool. And and the demo worked, including the CDP didn't make it barf bad. Yeah, right. Yeah, it's busted. That's okay. I'm not too worried about it. I haven't tried to make it work. The low-level code for listening to CDP packets is there, which is why it's hearing them. Right? It knows how to parse them and pull them apart, but I don't know what sense to make out of them, because the documentation of CDP is poor, and it looks like when you read several versions of it, there might be several versions which are different, and I think it's the kind of thing you might have to learn experimentally. And I haven't had any hardware. Actually, I do have a Cisco switch in the basement, but it's like you have to buy a license in order to use it. So I haven't used it yet. So anyway, you get the idea of the demo, right? Nothing here was configured. I didn't even tell it, because I used multicast, where the central server was. If I was on a subnet where the multicast worked, it wouldn't matter. One of the things I thought about doing, I'm going to probably do this, is have a bring your own laptop event where everybody brings their laptop and we make a data center and a graph out of everybody's machines, kind of on the fly. The script that I have now, Santiago can tell you it installs correctly. He's having trouble with it after he installs it. But basically, I have kind of a magical installer. You run it, installs it on the machine, and figures out what distro you're running and what packages I need to put on the machine and all that stuff. So all that stuff. So it's again hands off like all this is. So let's see if I can actually switch back to the other screen or not. Usually when I do this, well, anyway, I think we've done enough here. Done enough damage. Oh, okay. Well, I have run over time. I can stay as long as. Is there interest in the remaining people in hearing more or not? Huh? Yeah, no, that's okay. Anyway, I want to thank you.